In this video, I want to show you how to run t-tests in Jamovi. Let us first load our data set. This is the same data set we've used in previous examples and includes data for 47 children, boys and girls, some of which have Norwegian as their home language. So these are majority home language, and others have a minority home language. Some of these children participated in an intervention and the others were in a control group. And we have a number of measurements for these children, including a measure of nonverbal cognitive ability in kindergarten. That's what the K stands for. Measure of letter knowledge in kindergarten, receptive vocabulary in kindergarten, first grade and second grade. Word list reading fluency in kindergarten, first grade and second grade, and also the measure of word reading fluency after the intervention for those children who received the intervention and after the same amount of time for the control children who did not receive intervention. In Jamovi, like in many other statistical software programs, each row in this spreadsheet of data concerns one case. Usually, in our field, this means one person. Here it is one child. Therefore, when we talk about independent samples, this refers to different groups of children. Therefore, the different sets of values that we want to compare in an independent samples t-test would have to correspond to different rows. For example, if we want to compare the vocabulary in kindergarten between the two sexes, we see that we need the vocabulary variable for each child and the sex variable for each child. So the sex variable defines the groups by its values. So all the rows that have F will belong to the female group, the girls group, and all the rows that have M will belong to the boys group. Once you have your data sorted out in this way, we click on t-tests, independent samples t-test, and we can enter our quantitative dependent variable in the dependent variables panel, and our grouping or independent variable, which must be a categorical variable with only 2 levels, as a grouping variable. If we try to use a categorical variable with more than 2 different levels, this is not going to work because t-tests admit only 2 levels. If there are 3 levels or more in your variable, you will need to use a filter to only select the cases for 2 groups. As you see, as soon as we entered these 2 variables, we have received some results on the right side of the Jamovi screen. However, before we proceed to interpret those results, we first have to check whether our test is actually interpretable. We must go to assumption checks and click on the homogeneity and normality test. And it never hurts to take a look at the QQ plot as well. In this case, we see that the normality test, which is the familiar Shapiro-Wilk test, produces a non-significant p-value. This means that our data distribution is not significantly different from the normal distribution. This is what a normality test does. It tests the hypothesis that the data are in a different distribution from the normal distribution. Therefore, the null hypothesis for this test is that our data are in a distribution that is indistinguishable from the normal distribution. In other words, to pass the test for the normality assumption, this p-value must be high. It must be higher than alpha level, higher than the conventional level of 0.05, in which case we cannot reject the null hypothesis, which means that we do not reject the assumption that our data are consistent with the normal distribution. This is the case here. Then we look at the homogeneity of variances test. This is the Levene's test. This tests whether the variances in the two groups are different. Therefore, a statistically significant value here, a low p-value, would lead us to reject the null hypothesis that the two variances are equal, indicating that our two groups have unequal variances. In that case, if we had unequal variances, that is a statistically significant test, Levene test, we would simply need to check Welch's instead of students and use these values to report our t-test, because the Welch's t-test is one in which a difference in variances is accounted for. If we had received a statistically significant p-value in the normality test, this means that we cannot use the t-test, but we should choose the Mann-Whitney u-test, the corresponding non-parametric test instead. In our case, neither of these tests produce a statistically significant value. Therefore, we cannot reject either null hypothesis. We cannot reject the null hypothesis that our data distribution is normal, and we cannot reject the null hypothesis that the variances of the two groups are equal. Therefore, we can use the standard student's t-test. And we can also choose to look at the descriptives, a plot of the descriptives, the effect size, and its confidence interval. As you can see, this gives us all the information we will need to report. Here are the group descriptives that we'll need to report, the means and standard deviations. We can see graphically the difference between the two groups, and we can see the means along with their 95% confidence intervals, as well as the medians. And in the test results, this is the value of our t-statistic. So statistic goes with whatever is here. This is the student's t-statistic, the number of degrees of freedom, the p-value, and here's the effect size, which in this case is Cohen's d. This is the value of d, and this is the confidence interval for d. As we see in this case, the p-value is much greater than the conventional alpha level. This is not a statistically significant difference. We cannot reject the null hypothesis that girls and boys have the same mean vocabulary in kindergarten. And we see that the confidence interval for the effect size includes 0. So it starts with a negative number and ends with a positive number. So we cannot conclude that there is a difference in vocabulary between boys and girls in kindergarten. Let us look at one more example of this. If we go back and instead of sex, we use home language as our grouping variable, this amounts to comparing those with a majority home language to those with a minority home language on the majority vocabulary in kindergarten. As we see here, the homogeneity of variances test is not significant, which is a little suspicious because there is actually very few children in the minority home language group. There's only 8 children. This is a very small group, and you should never run analysis with such small groups. It is quite possible that the variances of the two groups are in fact very different, but the very small sample size for the minority home language group does not allow the homogeneity of variance test to be significant. Of course, we don't know that that's true, but we cannot really trust any estimates made on the basis of 8 children alone. So we're only proceeding for the sake of illustrating this example. As we see here, the normality test is actually not passed because this is a significant p-value, which indicates a statistically significant difference of our distribution from the normal distribution. Therefore, we cannot report this test. We uncheck students and check Mann-Whitney. And now this is our U statistic, the corresponding p-value. And this is what we can report when we want to compare the majority and minority home language children. Here are the corresponding graphs and the group descriptives that we also need to report. Let us now look at paired samples cases, a different kind of test. In this data set, we could compare, for example, the same kind of measurement across grades. Obviously, we would expect children to have higher scores on every kind of test between grades. For example, we can test the hypothesis that the children have a higher word reading fluency in grade 2 than in grade 1. These are the same children who have scores in reading fluency in both grades, so we are comparing score pairs that are on the same row. And this is very important for being able to run a paired samples test, that the paired samples have to actually lie on the same row in the data spreadsheet. This is very natural because the spreadsheet has one row per child, so this is how you would normally have your data in anyway. However, we're not going to run this test because it doesn't make any sense, because all the scores in grade 2 are greater than the scores in grade 1, which is, of course, what it would expect. Therefore, we cannot calculate a reasonable statistic using this method. It is clear that the difference is statistically significant, as there is not even any overlap. So we have to choose a different example for our test here. And we're going to check whether the children who received intervention improved in their word fluency scores. So that means if they had a greater word reading fluency score after the intervention than before the intervention. It's not enough to just compare these two variables now, because first we have to check to select only those children who received the intervention. So I clicked on filter, and I have to type that I want condition to be intervention. This is the value that I want to calculate the analysis for. So now all the control group children are deselected. As we've said, from a methodological point of view, this is not the appropriate way to run the study or the analysis, but here is just an example on how to run a paired samples t-test. So we have selected only children in the intervention group. We could also specify perhaps that we're interested in children with a majority home language as an additional restriction, because you might be afraid that the effects could be different for minority language speakers. So you can exclude those children, even if some of them actually received the intervention. And now we are ready to run our test. Going to analyses, t-test, paired samples t-test. We want to compare word reading fluency in grade 2, which is our baseline measure before the intervention, with word reading fluency post-test, so after intervention, for this selected subset of children. Before we get excited about reporting this, we should go and check the assumptions. As you note, there aren't any homogeneity of variance tests here, and that's because there aren't any groups, but just one. The paired samples t-test is just a one sample t-test, which is run on the differences. So there aren't any two groups to compare their variances. There's just one group, and all that we're interested in is its distribution. The p-value here indicates that there is no statistically significant difference from the normal distribution. So we're good to report students T for this comparison. And here is our T statistic. And here are the degrees of freedom and the p-value. And in case you're wondering if we can choose how many decimal places to show here, Jamovi gives us the opportunity of setting this. If we go and click on the 3 vertical dots to the top right corner, so below the X that closes the program and above the plus sign for the modules, in between, there are 3 vertical dots. And in that menu that pops out, we can choose number format. And Jamovi by default shows 3 significant figures. That means 3 significant digits, which means that it will show as many decimal places as needed so that we have 3 significant digits, 3 reliable places, no extra decimals. But we can choose to have, for example, 3 decimal places no matter what. Go back here, and so now we have 3 decimal places. You do not need to report T with 3 decimal places in any result. So this was just to show you how it's possible to change this. You should be reporting T with 2 decimal places. You can choose 2 decimal places here, or you can leave the default and get 2 or 1 as necessary. Most of the time, this is what you want. You can also choose here to show descriptives and plots of the descriptives. So we can get the mean and standard deviation for each of the 2 conditions. These aren't different groups now. These are different time points. They're before and after intervention. And these are the graphical representations, including means with confidence intervals and medians. Note that these confidence intervals are not relevant for our comparisons because we're not interested in the differences between children. We're interested in the differences between time points. And this is the QQ plot that doesn't show any reason to worry about deviation from normality. If we had gotten a significant p-value here, so a low p-value below the conventional alpha level, we should not be reporting students' t-test. Instead, we should be reporting the Wilcoxon rank test. And here is the W statistic and the associated p-value, which, of course, in this case is, again, statistically significant. There is no difference between these two in what the conclusion should be, either with the parametric t-test or with the non-parametric Wilcoxon rank test. We reject the null hypothesis and conclude that there was a difference between word fluency scores before and after intervention for this group of children. You can also report the effect size for the student's t-test, that's Cohen's D, and you can report its confidence interval if that's required by where you are submitting. And that's how you run a t-test in Jamovi.